Out of respect for everybody's time, let's get going, and we have a lot of ground to cover as well. So this webinar is going to consist of two parts. For the first part, we will have an opportunity to listen to our 4 unique perspectives on NB-IoT. Each speaker will talk for approximately 15 minutes. And then for the second part, we'll have a Q&A session. There we'll be taking your questions, and let's not take any more time and get out of respect for your time. And next up, we have Jamie Moss with ABI Research. Here he is, Jamie.
Thank you very much, Steve. So welcome everybody to this webinar. My name is Jamie Moss. I'm a research director at ABI Research, and I work within the M2M IoT and IoE team. I'm going to be talking to you today about the topic of module maturity within the NB-IoT market. And what we're going to do is explore the richness of the NB-IoT ecosystem as it exists today, to explain why now is the inflection point for the start of truly mass market adoption. And I want to begin by looking at one of the most basic requirements, which is, of course, having a network to connect to. So there's a few sources of this kind of information. And here at ABI Research, where we conduct market intelligence, we go directly to individual carriers in order to collect from them the latest information about the networks they have launched and the networks that they have planned in the immediate future. And year on year, we track the quantity of NB-IoT networks that have gone live. To date, the most dynamic year for network launches was 2018, where we saw a grand total of 43 individual networks go live. So that by now, in mid-2020, there's a total of 111 networks by our count currently live, supporting NB-IoT worldwide. And that's not all, because we know of another 22 that are currently in the planning and trial stages that do not yet have a final launch announcement date. When we look at all of these networks spread across the world and we see which regions they are in, that's shown on the pie chart that's on the screen now. And we have a third of them within Western Europe, 28% within Asia-Pac, and then a further 21% within Eastern Europe. The networks are spread very evenly throughout the world. The fact that there are so many in those particular regions is mainly down to the fact that there are so many individual countries in those respective continents. To compare NB-IoT to CAT-M, for example, we reckon that there's 40 CAT-M networks live right now, with 14 more planned, which goes to show that NB-IoT is far the most popular choice to date. I'd now like to move on to talk about the chipsets that go into the modules, that go into our devices, that connect to the network in order to provide us with NB-IoT connectivity. Most of the chipsets that have been developed by the major chipset manufacturers came out in 2017 and in 2018, in tandem with the bulk of the network launches that we've seen to date. There's a total of 28 chipsets currently available from some 15 vendors worldwide, 22 of them coming from the 9 familiar manufacturers that you can see listed on the screen right now in this timeline of NB-IoT chipset launches. Some of these chipsets are dual mode, so support both LTM as well as NB-IoT, and some of them are single mode only. They only allow for the provision of NB-IoT. We haven't had an awful lot of new launches in the last year, but we will have some more at the end of this, with new products coming onto the market from HiSilicon, the subsidiary of Huawei, as well as from Qualcomm. Why do new chips get launched? Well, a greater integration of previously separate components onto that one die, an increasingly small nanometer process for a smaller form factor, a lower cost, lower power consumption, and simplified end product development cycles, more already existing on the chipset, making it easier to build that connectivity into OEMs' devices. And of course, different technology combinations. We've seen it to be popular to combine LTE and NB-IoT with 2G historically in order to have global coverage and fallback. Looking to the future, what's going to become more popular is greater software customization on the chip itself by application, courtesy of more processing overhead being given over to SDKs and APIs that OEMs can code for to run bespoke software on the chips themselves. So these chips go into modules, the all-in-one communication hardware solutions that we can embed into our connected devices to solve that connectivity headache for us so that OEMs can concentrate on what they do best, designing excellent quality electronics products. There's 140 NB-IoT modules available in the market right now using the chipsets that we were just looking at on the previous slide. These 140 module products are distributed across some 32 module vendors, a very large portion of which are from China. So 20 of the NB-IoT vendors that we count as contributing towards this global NB-IoT module product portfolio come from China. The reason that they have so many is because they have an awful lot of band-specific variations, often tailored to individual carriers within individual countries. When it comes to NB-IoT, efficiency is very important, and customization is also very important to keep costs as low as possible and to make things as effective as possible on an individual carrier's network. We also have a number of different form factor variations with different connectors enabling them to be embedded into different types of OEMs devices. How many modules are actually being shipped every year? So here at ABI Research, we work very closely with manufacturers and vendors that are supplying the telecommunications and technology markets. And one of the things we track ever so closely is cellular module shipments, specifically for the IoT. And it took all the way up until 2016 for us to have 100 million shipments a year. Since then, things have changed dramatically. And what we're looking at here is historical data reported to us by our industry partners. It's now the case that that figure from 2016 has nearly trebled. In 2019, we saw just under 300 million modules being shipped specifically for use by the IoT. And we can also see, very importantly, that since 2016 until now, 4G has become the dominant driver for IoT connectivity and for module sales. We also have here the increasingly important LPWA LTE segment. This is the combination of Cat-M and NB-IoT in terms of module shipments. 5G is only just coming into market, and we saw our very first units being shipped late last year. We think of LTE-M and NB-IoT for the time being as effectively being aligned to 4G. However, in time, of course, it's going to be part of the 5G standards. So to move on to look at NB-IoT specifically, by our calculations, 70 million NB-IoT modules, some single mode, some multi-mode, will be shipped this year. Last year, just over 40 million were, with the very largest vendors of those modules shipping up to 20 million units all by themselves. The long-term projection that we see when looking at the marketplace, talking to OEM vendors, understanding their connectivity requirements and the connectivity technologies that they're going to build into their devices, and the shipment expectations that we see for those devices and for the NB-IoT modules that go into them, allows us to believe that come 2024, at the end of our current forecast horizon, we'll be looking at a market where there'll be 550 NB-IoT modules shipped around the world annually. One of the key drivers for this increase will be the pricing. And the pricing has been falling very steadily, very consistently, but in a stable fashion ever since the launch of these products. Going back to 2017, when we saw those first chipsets becoming available, we can see that an NB-IoT module was priced at a little under $10. And this was generally thought at the time to be far too expensive to ever be genuinely mass market, for it to be affordable to embed this technology into all of the devices and the sensors that we would like to. But by the end of this year, we'll have seen that average selling price, that ASP for an NB-IoT module, having fallen to almost exactly $4 a unit, with the potential to reach $2 by 2024, at which point we will have surpassed the $2.50 sweet spot, whereby we believe that it will be necessarily possible for NB-IoT to be affordably embedded into the great majority of wide area connected devices. What is it going to be used for? This is the 2020 outlook. We take into account a total of 32 markets for different device types and the application of cellular connectivity within the IoT. And we can aggregate them into these 6 that you can currently see on the screen now to understand where it is that NB-IoT technology is currently being used. And as of the end of this year, the NB-IoT connections that are going to be out there are going to be predominantly used within the metering sector. And that's encompassing smart meters as well as gas meters and water meters too. Other key markets will be tracking and location. And when we say this, we're talking about asset tracking and fleet management, and even people and pet tracking and inventory management. And then smart home will be an increasingly important sector too, where we're looking primarily at the emerging markets of home security and automation, which are receiving quite a boost right about now, with more and more people focusing on their immediate environment, their home environment, also becoming their office environment. In order for us to have mass market adoption, we need to have affordable pricing plans. So of course, we pay close attention to what operators are offering. Most carriers do still currently ask enterprises to inquire for NB-IoT pricing, but public plans are available, and they tend to be on a monthly allowance per connection in a very similar way to consumer tariff plans. It's unusual for there to be any overage pricing, and the maximum allowances are small by the measures of a consumer's plan. We may also see NB-IoT being bundled into plans that incorporate other network technologies. So it's not just for NB-IoT connectivity, but it can also cover 2G, 3G, and 4G. And there will often be throughput restrictions, which you can well imagine is necessary in order to keep so many potential devices connected simultaneously. NB-IoT allowances typically can't be pooled between devices, although the price per connection will often be tiered based upon the number of connected devices that an individual enterprise or a municipality wants to purchase connectivity for. And unlimited plans, yes, they do exist, although right now they're relatively uncommon outside of China, as are multi-year plans per device. Although these are actually, in my opinion, some of the very best plans, as they force enterprises and municipalities to commit to a long-term strategy for connected devices and to do so in bulk. The price per device becomes minimal, giving them the best cost control over time, and it encourages the application of the NB-IoT connectivity to be very well thought out and part of a long-term use case. So while there's not a huge amount of consistency in pricing across operators right now, I would say that rather than worry about the price per megabyte, we should be concentrating more on the value of the work done, what can be guaranteed for an enterprise or a municipality operationally as a result of having this connected infrastructure in place. And when it comes to pricing, simplicity has to always be the key. So as we start to finish up, I wanted to show some of the devices that are currently proliferating in the NB-IoT space. Now, every single one of these was selected not just because it can use NB-IoT, but because it specifically does and doesn't use other connectivity technologies. We can see how these device types that are becoming more and more readily available fall into these 4 common categories of alarms and trackers and meters and sensors. And some of these things can seem very specific, like a manhole monitor or a trash bin fill sensor. But there are very valuable long tail applications out there, and there are countries in the world where the removal of manhole covers for the sake of selling the metal is a genuine problem and can lead to damage to public utilities infrastructure, and can lead to lots of accidents on the road when things fall into these exposed manholes. The IoT is very much a market of long tail applications that add up and that might not sound very sexy individually, but constitute something very big overall. And carrier awards are also picking up. So the number of operators around the world that we see signing large NB-IoT contracts with their customers. The four on screen right now are centered around China and the Nordics. The variety of connections that they enabled at the time that these announcements were made varies a lot, as you can see, from 100,000 up to several million, down to as low as 68. And this is one of the most interesting facets of NB-IoT, its scalability. It was always difficult in the past for carriers to be able to effectively support organizations that had relatively low requirements for the number of connected devices that they wanted to enable. But you have to start small in order to scale to be large in the first place. And with mass IoT connectivity and NB-IoT, this starts to become a lot more feasible. So let's summarize. Historically, we've had network rollout delays. We've had coverage issues. We've had a lack of roaming. Module and chipset pricing has been too high, and carrier pricing has been uncertain. Most importantly, device OEMs were learning what type of connectivity they needed across the plethora of different technologies that we currently have. But here today, we've got 111 networks live for NB-IoT. 20-odd chipsets, 140-odd modules, 42 million shipments of modules last year, which is already nearly 15% of the entire cellular module market for IoT, and even more shipments when we consider the devices out there that don't use a module and just embed a chipset directly. How did we get here? Standards have played a huge part. What's the future going to hold? Well, now that we have all of these essential physical components in place, we've got to get that data to the cloud, make it usable for the OEMs and the enterprises and the municipalities with the connected equipment, so that they don't have to become telecommunications experts, so that they can focus on doing what they do best. Intelligent device-to-cloud management systems are going to be absolutely vital as we enter this mass market stage of NB-IoT. So with that, I'd like to thank you very much for taking the time to listen to me today. And I'm going to hand over to Jens Olek from Deutsche Telekom, who is the head of new access technologies. Jens.
Hello, thank you very much, Jamie. So hopefully you can hear me. My name is Jens Olek at Deutsche Telekom. We have an IoT unit, central tribe to promote and market IoT and develop IoT for Deutsche Telekom. I'm very happy to be here. We are working in particular on access technologies such as NB-IoT and LTM. So I'm going to provide you an operator perspective on the market of NB-IoT, adding to what Jamie has already provided from a neutral industry analyst perspective, and what Adem and David will also provide more from a software and standards perspective. So first of all, why did Deutsche Telekom invest into NB-IoT? So that decision was about 5 years ago already. We already saw that there will be a high need for massive IoT use cases, being use cases for very low power and low price devices, simple devices that cannot properly be served by existing 2G, 3G and 4G networks, mostly because of performance issues in terms of, or price issues in terms of the 4G modules are far too expensive and 2G and 3G modules are too power hungry to serve those low-end use cases. Therefore, as most of you will know, NB-IoT and LTM have been standardized by the 3GPP, and we've evaluated several technologies. We've also evaluated some proprietary technologies based on unlicensed spectrum. At the end of the day, we concluded that we as a global operator need to really go for an industry standard based on licensed spectrum, and most importantly, reusing existing network infrastructure. So largely based on the software upgrade of our radio access networks, plus a few components in the core. And we also, of course, want to be future-proof, as Jamie has already mentioned. NB-IoT and LTM are based on LTE, but they are part of 5G and are the 5G standard for massive IoT use cases. And we've decided, choosing between NB-IoT and LTM, to go with NB-IoT first, because this was the biggest gap for us for those low use cases, whereas LTM is currently already still being served by 2G and 3G, but will, of course, I'm very sure about this, gradually take over from them. Could you please advance the slide? Okay, so no, this didn't seem to work. Here we are. So, so let me quickly provide you an overview of what we've been doing over the past 5 years. So, back in 2016, we've created first prototypes of NB-IoT before it has actually been standardized. Then we also created a first end-to-end solution. So we demonstrated for ourselves that NB-IoT is not just a specification, but also reality. Okay, can you move on, Steve? Okay, so in 2017, we've commercially launched in 10 countries, 9 of them in Europe plus the US. Next one. In 2018, we've started working on roaming. We've performed the first successful roaming trial together with Vodafone in Europe, and we've also continued improving our network and checking it. We did a very large indoor measurement campaign to prove that you can reach many devices even indoor. Okay, and in 2019, we've by the end of 2019, we had coverage, nationwide coverage in 7 of the 10 countries. We've introduced roaming capabilities for our own footprint, and we've unveiled something called NewSim. I'll come to this in a minute. Stay tuned. Next. And in this year, so far, we've struck first NB-IoT roaming agreements. You might have seen it in the press, together with Vodafone, Swisscom, and Telia. So this is hopefully the starting point for a more seamless roaming across Europe and hopefully then the rest of the world soon. We are working on launching LTM in the first countries soon. And for NewSim, there will also be first chipsets and modules coming up in the second half of the year. Can you move on, please? So for regarding the use cases from our perspective, so Jamie has already given an overview. I think it's also a nice exercise to do a quick retrospective. What did we actually think back 5 years ago? So if you look at our kind of top 10 list of use cases by deployment, according to our observation, definitely, as Jamie said, the metering use cases are at the top. Use case that we didn't really expect that much back in 2016, 17 were things like very simple things like smart buttons or trackers, smart buttons being an extremely cheap kind of device. Fill level monitoring, not just for trash cans, but any kinds of containers. Lighting monitoring, it's also big, maybe not as big as we thought back then. Smoke detector, smart parking is reality, but maybe not on every single parking spot. And other things like smart price labels are also coming up. So I think there's a wide variety. Ask me again in 3 years' time about the top 10 list. There might be use case that we can't even think of today. Let me mention LTM as well, because I think this really belongs into the picture as well. So LTM, also known as LTE Cat-M, in my view, bridges the gap between what we call, of course, massive IoT and critical IoT. So it's in the middle of, can you just show the use case, please? In the middle of the really simple NB-IoT use case with very little data, and the high performance use case with loads of data, and on the right side with LTE and 5G new radio, of course. In this case, you will have expensive devices, high power devices, which on the left hand side, the extremely low power devices and low price devices. LTM is just in the middle. I guess it will be the main substitute substitute for 2G and 3G, and I predict a golden future for that as well. In terms of the obstacles, I mean, let's talk about what kept customers from deploying huge amounts of devices within like the first 1 or 2 years of NB-IoT. I mean, NB-IoT is a new technology, and I think there are typical obstacles pertaining to any new technology, and those are being solved now. So this is my main message. Jamie has already mentioned a few things. I'll go through these points in a minute. So insufficient network coverage, of course, no roaming possible yet, modules and devices too expensive. Jamie covered this as well a bit. Connectivity prices are going down, technical issues are being solved. After my presentation, we'll also talk more about the software side, where there's a lot of standardization happening, which is good news. And of course, as for all technology, lack of knowledge on NB-IoT. Can you move on, please? So in terms of the launches, so this is the map of the GSMA who's collecting NB-IoT launches. It's always, of course, a matter of how you count it. So 94 commercial launches have been reported officially. There are some further unofficial launches, so it's certainly more than 100 or 110 launches in 54 markets to date, which is good news. I think when many operators are have now concluded their NB-IoT deployment, they will also activate LTM soon. So I predict this map to turn purple, very much so, in the next few years. In terms of roaming, as I mentioned, we've started our first roaming agreements with the first operator. So at the moment, we can cover 18 countries so far. Of course, there are a few gray countries on the map, but those roaming agreements are also in preparation, and I think this is really now picking up momentum, and we will have more roaming agreements to be seen. So regarding new SIM, so I mentioned this a while ago. So new SIM is about, at the end of the day, reducing device cost. So how do we do this? What does a device cost drive? I mean, certainly the radio module. We've said that the major radio modules have come down a lot. Back 4 years ago, there was the big discussion. About when NB-IoT modules will become cheaper than $5. I think we've already reached that industry target. That's great, but still there's the SIM card as a separate component in a device, which is costly, which also consumes battery and increase the form factor, and also you will have a logistics and purchasing expenditures for that. So we have together with many other partners, chipset vendors, module vendors, and security software companies, developed a de facto standard called NuSIM, which gets rid of the SIM card. So the SIM card functionality is being placed in the cellular chipset and in the cellular module. So in the second half of this year, the first NuSIM chipsets and modules will hit the market, and when you use them, or when you deploy them in your devices, you will not require a separate SIM card anymore, which I think is great news. So Deutsche Telekom and a few more operators will be offering new SIM. So yeah, please get in touch with us or talk to our ecosystem partners on this. Yeah, we talked about technical issues. NB-IoT as a global standard is gradually being approved. So we have released 13, 14, and 15 now defined. As an operator, we always strive to implement the next features, always, of course, subject to availability on the vendor side, on the device side, of course, and on the network infrastructure side. So I won't go, obviously, I won't go through every single feature on this slide, but as you can see, many, or most, released 13 features have already been deployed at Deutsche Telekom on the different countries. This is Deutsche Telekom view, but this is very similar to what other operators are doing. Same goes for release 14 and 15. We're working on many of those features, and they will gradually be deployed as we speak. Right. Before we come to the Yeah, the knowledge and communication side. Let me just clean up with a few common myths with NB-IoT. We've been reading a lot of reports and comments on NB-IoT, and I would just like to clarify a few things. So sometimes I read that NB-IoT is a separate network. So please bear in mind, NB-IoT runs on existing networks. Unlike other call it non-3GPP or proprietary networks, NB-IoT does not require separate base stations or gateways. So you use the existing LTE hardware, and you need to run software upgrade. So for an operator to really run a countrywide network, to have like nationwide coverage, it's much cheaper to do it via NB-IoT than by setting up anything on top of that. Secondly, a very popular a popular understanding was that batteries always last 10 years, whatever you do. So certainly the battery lifetime of a device always depends on several factors. So it's transmission frequency, power saving features, or which ones are you using, what coverage conditions have you got, what CE level are you using, coverage extension level, and of course, what's your battery capacity. So yes, you can definitely have battery lifetime of 10 years or even 11, 12 years, even more. We have a nice service in place called IoT Solution Optimizer to simulate this. There are other ways to simulate it. So yes, batteries can last 10 years, but I don't expect battery to last 10 years if you insist on this, for example, daily status updates, then it will likely not work. Next point, sometimes I read that NB-IoT is just for stationary applications. It's not really true. I mean, yes, metering will probably be the most, or at the moment, the most common application, but you can use NB-IoT in mobile use cases. You have not got seamless cell handover, so you don't have voice calls that are handed over from one cell to the other while you're driving on a motorway. But for NB-IoT, since you're talking about infrequent status updates, a seamless cell handover is not needed in our view, but fast cell reselection is possible and sufficient. Of course, you need to bear in mind the battery consumption. So a meter, like a heat meter that could last 12 years, in operation, while a tracking device might not last 10 years, but still it's much more power efficient than any other technology that I'm aware of. Next one. Not designed for roaming. I would say NB-IoT was ready for roaming on day one already. So as we were able to demonstrate with Vodafone very early in the game, it's not a problem to get devices roaming in other networks. What we had to work on as an operator community was a new charging model to account for the very low volumes of data. So we had to agree on a new charging model. That we've done this via the GSMA, and we are as an operator community implementing it. So it works well, and now the commercial side is getting in place. So NB-IoT is definitely there for roaming. Last point, I mentioned, I can't repeat it often enough. It's no question whether NB-IoT will be replaced by 5G or whether it will become obsolete by 5G. They are part of the 5G standards. Please take a look at the 3GPP publications or GSMA publications. You can assure yourself. So last point from my side before I hand over to Artem, regarding knowledge. There's a lot of knowledge on NB-IoT out there. Can you please move to the next slide? There's a lot of knowledge on NB-IoT out there where I think the whole ecosystem is getting smarter and smarter. We learn a lot. So from Deutsche Telekom side, we're contributing an open developer community, an international developer community. You can find it at iotcreators.com. You can always pose your questions and get your answers from Deutsche Telekom experts, as well as loads of other experts and developers around the world, or even attend one of our events. So we're really happy to be transparent and open with the knowledge, because I think that we really need to collaborate since it's still new technology. Great, that was my presentation. I'll hand over to Artem and later to David, who will talk about the software side of NB-IoT. Artem, please go on.
Yeah, thank you, Jens. Thank you so much. Hi, everyone. I'm so happy to be here. My name is Attendees. I'm the co-founder and CEO of IoTerop. We are a leading provider of device management solution for massive IoT deployments. Just a word about who we are. IoT scaling is not possible without standard. We believe in standards so much that we are a member of the board of directors of the Open Mobile Alliance, and we are deeply involved into the OMA, Lightweight M2M, IPSO, and co-op standards at IETF. We've done significant contributions to the Lightweight M2M 1.1 specifications, so that's to optimize its footprint in addressing the low power networks. We've been the first one to provide a commercial grade implementation of Lightweight M2M, especially designed for low power devices. And today, we'll cover together why device management is really important when planning deployment and scale, and how NB-IoT and Lightweight M2M are actually a perfect combination if you really want to put in place sustainable IT solutions. Our customers use our device management software to deploy the most advanced smart lighting, energy, water, asset management solutions. What do they really care about? Well, most of the time, our customers are targeting the conception of a device that can fill a global deployment. Considering massive deployments mean it's really key for them to lower the CapEx and their OpEx as much as possible. And the performances of NB-IoT allow them the possibility to create a new generation of devices, extremely energy efficient, able to communicate securely from all over the world. And those devices have enough now bidirectional bandwidth so that to address interesting use cases with value-added services involving device management capabilities. Our customers really care about data reporting efficiency and device management. These are absolutely key to lowering costs and create sustainable solutions at the end. NB-IoT meets the expectation of our customers from a pricing, a power, and coverage standpoint. However, NB-IoT, as Jens mentioned, is different from other cellular technologies in terms of bandwidth, latency. What actually works over 3G, 4G, and maybe LTE-M may not work over NB-IoT. Standards really reduce the complexity. With NB-IoT, our clients can create a single device, a single SKU that they can replicate and deploy all over the world. Relying on the most open relevant standards reduce their engineering efforts, and they can ensure a faster time to market. Where storing a prototype on NB-IoT is fairly easy, right? You just buy a board from the market, but did you really think about your solution scaling, the security framework you're gonna use, and the overall bandwidth consumption and associated cost to it? With NB-IoT, you can ensure robust security from your device communication. Exchanges get authenticated, encrypted. However, securing an IoT devices is not like securing a PC. Our customers need to address device limitations in terms of footprints, battery consumption, CPU power, and meeting the NB-IoT constraints. Operating security and communication over NB-IoT is really a challenge, and making the wrong technical choice here can literally kill your business ROI. Let's take an example. In the asset management, so where a customer device connection can break often, or simply when those devices need to go to sleep often. Depending on what security layer you implement, resuming your connection often can literally kill your device power and data consumption overhead. Well, let's take a look on the left side with an MQTT-based approach. So this one is relying on TCP TLS. In that case, resuming your connection will result in redoing the TLS handshakes. And it will require a lot of time, a lot of network traffic and power. And let's compare it to a CoAP-based approach relying on UDP and DTLS with connection ID support. Well, this will result in it being a much lighter alternative. So the difference between the two approaches is really huge, right, in reception. So multiply this difference by the number of deployed devices. Well, this is really key. You need to take this fact into consideration. Well, you can bypass this limitation by relying on a private APN, but that provides that your telco offers ciphering on the control plane, and you have a dependency with the network and can bear significant cost for that. Our smart metering customers discover most of the time that they have too much overhead when using MQTT. Indeed, low power smart meters usually need to go to sleep as often as possible. So the latency, the bandwidth limitation of NB-IoT cannot usually sustain the resumption overhead caused by these TCP TLS-based connections. So co-op in that case remains a much better alternative for smart meter communication because UDP makes it much lighter. Co-op is also interesting because unlike MQTT, it can also operate over non-IP networks. And so it will be a working solution for telcos operating NB-IoT and IDD networks. There are other alternatives to co-op, typically like MQTT-SN, but this latter suffer from a poor adoption and still remain pretty fat in terms of network payload impact compared to co-op and DTLS. With our smart lighting customers, well, power is not an issue. So why shouldn't our customers then maintain the connection between the cloud and their endpoints always open and so avoid this TCP/TLS resumption overhead? Well, it's because TCP works in connection mode. And it means that you reserve specific network resources on the cloud side to maintain each open connection, and you get billed for that. So when you have a lot of endpoints to handle simultaneously, well, this creates a huge impact in terms of cloud resource needs, consumptions, and costs. So in addition, there are certain clouds that just cut the TCP connection if no traffic is detected for a few seconds. So typically that brings back this TCP/TLS resumption overhead, and sometimes very painful for just sending a few bytes. In that case, as UDP works in connectionless mode, co-op over DTLS offers an interesting alternative to lower the cloud resource impacts when dealing with massive IoT deployments. I will expose a bit later what we've put in place with Itron in the smart lighting area in order to pilot dynamically the data management so that to cope with those constraints. Well, our customers not only need to convey the data to the cloud, but they need also to operate and manage their massive fleets dynamically and remotely. Co-op, MQTT, MQTT-SN, they're just transport. They don't define a data model, nor critical common services for device management. And our customers really need to have a way to bootstrap their devices, provision, change security keys, certificates, configure their device parameters, change their data reporting policy over the years. And most importantly, they need to have a way to update the device firmware so that they keep the software always up to date. OMA Lightweight M2M is a standard that has been especially designed for constrained devices and that can operate device management functions over any transport, any networks in a very light way. Lightweight M2M has everything needed to cover massive IoT deployments. It also includes an efficient data semantic relying on the IPSO standard that is used by the large smart meter manufacturers today. In the lightweight M2M 1.1 version of the specification, the OMA added the support of NIDD and especially optimized the registration process, exchange formats, and some RESTful mechanisms like the composite operation that makes lightweight M2M even lighter over NB-IoT. The lightweight M2M 1.1 leveraged an interesting concept of IETF OSCORE security, which offers an end-to-end encryption and authentication mechanism at the payload level. So this layer is very interesting as it is much lighter than DTLS TLS and can work over NIDD. And in the 1.2 version specification of the lightweight M2M, the OMA plans to make lightweight M2M operate over MQTT transport. So that will be offering the possibility for legacy MQTT adopters to onboard interoperable device management capabilities in their solutions. Well, just a word about the implementation. Not all the lightweight M2M and co-op implementation are the same. Where you are a device maker and you plan for massive IoT deployments, you really care about your device flash, your RAM, your CPU and power consumptions. The performances of your software is key there. Controlling your bill of material is really key because when you save on the bill of material because of the performance of your software, well, you save the corresponding cost replicated to several hundred of thousands and potentially millions of units. So this is why at IoTerop we created IoTerop's IOA. And IOA is an implementation of lightweight M2M that has been designed especially to be light and portable and to be included into any hardware, even the very low power MCUs. IOA software allows you to lower significantly your device capex. It's a ratio of 10x to 20x better performance than other competitive implementation and much lighter in terms of footprint and RAM consumption. So IOI is here really to reduce your engineering costs. It's very easy to port on any hardware and without any knowledge of the lightweight M2M standards. So be careful, because modem providers sometimes they provide a built-in lightweight M2M implementation. Usually it's 1.0 only. It's extremely basic and it's limited to only modem-based operations, right? So what do you do when you have a device-centric or application-centric management operation to perform? It will not be available for the modem, right? So this is why most of the time, the device maker prefer to have an efficient stack running on the MCU, so that to be able to handle the device side and application-based management operations. And it also an advantage is that when you change module maker, right, you don't have to redo all your application logic. So IOI is a perfect fit for that. When deploying massive IoT devices, our customer really care about keeping their operational and maintenance costs the lowest possible. It's not a fire and forget scenario. They need to manage their devices lifecycle in a proper way. So you absolutely need lightweight M2M server so that to be enabled with lightweight M2M clients, right? And lightweight M2M 1.0 can be appearing too fast because the optimization that have been done on 1.1 are critical for NB-IoT. So this is exactly why we developed a device management platform named Alaska. It has been built to address massive IoT fleets lifecycle management and lower corresponding OpEx as much as possible. It really responds to critical expectation of our customers, right? They need to make sure they can provision their device with the correct security keys, certificates over the air. They need to configure the connectivity, the behaviors, where they send the data to, and this needs to work seamlessly across the device portfolio. So this process, and this is the difficulty of having a platform like this, is considering large fleets of devices and meeting the NB-IoT constraints. This is why Alaska leveraged fully on the lightweight M2M 1.1 standards. And that's the only way to keep the work efficient on that NB-IoT device, where other implementation will create overcost on the cloud side, but also impact significantly the overhead on the device side. Our customers need also to put in place advanced use cases like remote diagnostic, to fix unexpected behavior or misconfiguration they would foresee after shipments. Sending someone to manage such problem is not an option, right? So our customer, they don't expect to have their devices fleet software remain static or even their security to remain unchanged. They need to adjust their device behavior to meet market evolution. They need to have a way to update their device firmware efficiently over the air. And those are critical device management operations that are pretty complex, and you need to rely on an efficient lifecycle management software like Alaska that follows standards and data models evolutions. So it's really critical to leverage on standard to do that. Well, here is an interesting approach that we developed with certain customers like Itron in the smart lighting area. The idea is that how do I deal with my deployed devices that are already transmitting data over MQTT, right? So I can't change everything. Well, you can still work in an hybrid mode. So continue doing data reporting on MQTT if you are really obliged to, and do device management operation using lightweight M2M over NB-IoT. An interesting concept that we put in place is that we register dedicated object model to support the possibility to open, close the MQTT topics and channels remotely. And correspondingly, this is really interesting because it can lower typically the impact on the cloud side in terms of resource and cost, while piloting dynamically those data management operation is really critical and very interesting. Another approach where typically you have your backend application server that are only supporting MQTT and you can't change it, right? So we have a way to, for example, on the device side, you can switch your data reporting to be relying on co-op DTLS. So in that case, it will be much lighter and go over the NB-IoT latency and bandwidth constraints. And on the server side, this is what we've done inside our platform. We can transform dynamically the co-op traffic into the MQTT, leveraging our own MQTT broker. And this latter is bound to the legacy native MQTT backends and no change on the cloud application side. In any of those two solutions, the real challenge, and this is the strongest one, is to solve the security issues at every level, from the devices to the backend, from the bootstrapping of the devices until it's fully operational. Well, an experience from the field with our smart metering solution provider and customer, Advanco, they really choose our solutions in order to speed up the time to market in launching product over NB-IoT. Well, they first started with an open source implementation, a lightweight end-to-end open source implementation, well, namely Wakahama, that we actually contributed to develop and we continue maintaining. Well, they soon realized the significant investment for them needed to fill the technical gaps and be able to achieve a commercial product with it. Well, instead, they licensed Iowa, and they could actually keep their costs very low and under control. Anyway, the open source stack was not able to meet the constraint of the hardware in terms of memory and CPU power, and even meet the constraints on the NB-IoT challenge. So they started to perform the application logic based on an API documentation, and we sent an engineer. Within a couple of hours, well, the stack was ported, and we did successful lightweight and 1.1 exchanges on their prototype, on their hardware using NB-IoT. In less than 3 months later, their product was launched and already pre-certified with Telco. So it's excellent use of expertise and efficient solutions. Well, so of course, we'll be more than happy to discuss with you if you have any NB-IoT developments and products in mind. So please keep in touch. I'm handing back the microphone to David Howard, the senior principal architect at our beloved customer, Itron. It's up to you, David.
Thank you. I'm David Howard. I'm a senior principal architect and research engineer, Itron Idea Labs. Idea Labs is an innovation unit within inside of Itron. Let me go ahead and advance this. Did you give me the slide advancer? Nope. So sorry. Can't see the advance on mine.
Bottom right. Click on the bottom. No. There.
The advance. There's okay. They are showing up now. All right. Sorry about that. So who is Itron anyway? Itron is a utility and smart city solution provider. Primarily been involved in the last 25 plus years with electric, water, and gas metering solutions. More recently through acquisitions, public lighting, traffic, parking, safety, and other smart city and campus area applications. Pretty sizable company. Literally have millions of devices deployed and under management. 8,000 people across the globe in our various offices, and a very large partner and ecosystem of solutions. So what are we involved with? We're working at innovating solutions across the IoT space. Again, starting with the smart city and utility area, but trying to build out many different applications and solutions. And toward that end, one of the issues is that we use many different kinds of communication technologies, basically everything, proprietary, cellular, MASH, star, drive-by, as well as hybrids of all of those. We frequently have hierarchical networks, so network of networks. And some of them are licensed, some are unlicensed. There's a mix of that as well. We have constantly powered devices. We have low energy devices. We have battery devices, some of which have requirements of greater than 15-year lifetimes. So you think water meters and gas meters. We have very long lifetimes required on those. Most of the large utility networks are customer owned. So we sell basically a solution to large investor-owned utilities, and then we maintain those. We operate and maintain those for them with SLAs. A lot of the cities that we're working with worldwide are choosing network as a service. So we actually own the network and deploy it. Some of the networks, so in all of this, we're heavily involved in standards, including IEEE, IETF, OMA IPSO, many others. The work that we've done in Idea Labs, I believe, that NB-IoT is a critical new tool in our toolbox of connectivity that we can utilize to provide outcomes for our existing customers and provide a growth path into new customers and businesses. So the three kind of main points that make the NB-IoT attractive to us at this point is its very widespread adoption, the hardware maturity, and the protocols that are now standardized with it. So we'll start with the adoption. As others have mentioned in this presentation, there are now many millions of connected devices that are utilizing the NB technology. It's growing very rapidly, both from a carrier standpoint and a deployed standpoint, and the numbers are accelerating. We, as Hatem had mentioned, we worked on developing kind of a generic NB solution, which involved some of the standards in the idea that it would be good for developing internally and for helping partners develop new devices. The global service is available, and we've tested this all over North America and APAC and EMEA, both in M1 and NB1. The kind of management alliances that are now in place, companies like Vodafone and T-Mobile that are putting alliances in place for service, as well as quite a few MVNOs that now have kind of a global footprint. This ability to have embedded or even the integrated UICC and SIMs, as was previously mentioned, is a huge benefit as well that speak to the maturity of the modules and the technology. And it simplifies creating a single SKU global product, which, you know, if you're a company with a global footprint, the ability to have devices that are built that work anywhere in the world really simplifies the supply chain. So we'll go on to a little bit to the hardware maturity side of it. You know, early on there wasn't a lot available. It was a little bit you know, hit or miss whether it worked in places. Some of the things weren't settled down both on the networks and the modules, but now we are at a point where there are, you know, really a lot of different companies, both on the chip level and the module level that we've worked with and that we've tested over a very wide area. There's some differentiation in on the battery side or the low energy side. Some are, you know, a little more efficient than others, especially with things like EDRX. So depending on the application, you might lean one way or another. But again, since we're trying to make it easy for third-party developers to bring new devices on our system, we can't really specify, you know, thou shalt use this or thou shalt use that. We want to have a kind of a generic solution and let them do their differentiation by choosing which modules make sense for their application and for their devices. The target products here, again, are smart city, street lights, single SKU, small scale, then grow to large scale, gas and water, which are battery life issues. All of them need to be global footprint. You know, there may be situations where the modules are, you know, regional to get cost benefit out of them, but in most cases, these are all available global as well. The prices for modules, the maturity for us is that, you know, prices have come down to a point where they're well below $10, in most cases below $5 in relatively low quantities, which make them very attractive for the kind of applications that we're looking at. Oh, crap. This thing just loses the buttons on me. There they are. All right, and then the other thing that speaks to the maturity is the number of carrier approvals as well as regulatory approvals for the modules. I use two examples here. One is a Quectel showing their system that's based on Qualcomm. Many different major carrier approvals already, and regulatory approvals all over the world. And then even the newcomers, relative newcomers like Nordic, have relative, regulatory approvals, basically worldwide footprint. So clearly the modules have gotten to a point where they can be used in worldwide kind of products. And so the part that I'm actually most interested in, the adoption and the hardware maturity are great, and those are prerequisites. But the piece that's very interesting to me now is the fact that security, application, and device management protocols have been standardized and are now actually embedded on and extensible on the NB modules themselves. So that's a very powerful feature. Because the way that you used to build a device, or that a third party would build a device, is they literally had to build and support and regression test every layer of the stack. So if you look at the legacy side on this slide, it used to be the device maker's responsibility to, not only do their application, but they had to support all of the protocols underneath that, as well as some connectivity into a modem or a modem chipset. The way that it's done now with NB-IoT and M1 is the device makers can basically just focus on their application data and device attributes, and the rest of the stack can be embedded on the module. That way the costs are spread out essentially over all device makers and all applications. So that's quite powerful and will really lower the barrier to entry for new devices and pump volumes up. It's important because it's essentially reducing the time to market for the next thing very dramatically. There's no reason that the application and developers of devices have to have expertise in-house in esoteric security protocols, the IP stacks, device management, application protocols. All of that's kind of abstracted to an API at this point, or can be abstracted to it. And again, as I mentioned before, the module that are available in multiple sources, and high volume prices are driving the prices way down. So kind of a reference architecture and show where the standards play into this. We have essentially the device maker focusing only on the application side of it and an API. The data models for attributes and data objects can be defined in a public or even a private way using the OMA Alliance and lightweight M2M. And I'll show you a little example of that in a minute. And then the actual stacks underneath that are defined by IETF and 3GPP. Again, the thing maker focuses on where their value add is, instead of having to have expertise on every layer of the stack. So one thing that enables this is lightweight M2M. And so I've shown some of the core functionalities of what lightweight M2M can do. It's bootstrapping of the device, it's device configuration, it's firmware updating, it's fault management, it's configuration and control, and it's reporting. So very important things that are kind of common mode for all devices. And it allows you to do full life cycle management. So from acquisition of the device, to configuring of the device, to deploying the device, to managing it during operation, to retiring it. All of that can be handled through objects and protocols that are defined through lightweight M2M. Of course, the issue here is that, you know, the initial lightweight M2M client, as was mentioned, that was put on most of the modules that are out there, may not be up to the latest standards, but thankfully the modules have extensibility capability on them, so you can actually load updates or new agents or new pieces of protocols and then use them, and that's kind of what we do. And the lightweight M2M adds a couple of really important features. It essentially gives you the ability to have better support for public key infrastructure, support for application layer security that's based on OS core if you should want to do that, performance improvements by having the capability to do composite read, write, and observe, as well as support for CBOR, so you have compressed, highly efficient transmission of the objects and attributes. And I'm going to give you just a little example of what, if you're not super familiar with lightweight M2M, what it actually looks like. So this is part of the definition from a tool that OMA provides, an online tool. You can basically define your attributes. The one that's shown here is one that's already been defined, but you could go in and edit this if it wasn't exactly what you wanted and create a new one. And essentially what it does is it has an object ID, in this case 3303. It describes what it is. In this case, it's a simple temperature sensor. And then it has the actual resources defined and, you know, how many of them exist, whether they're, you know, integer or floating point, whether they're readable, writable, executable, all of the kind of things that you would want to do with a data object. And I'll give you one more example. Here's another one, which is lighting control. This is one that was used in the example shown by Hatem, and in a street light example that we had developed as 3311. It has dimming capability on, off, et cetera, et cetera. There are ones for metering, there are ones for water and gas metering. There are, you know, literally hundreds of different definitions already available, and then you can, you know, mix and match and put things together and create your own as needed. So it's a very extensible way of creating object models and attributes that are then handled, managed, read, written, and observed using standard protocols and security. And here's an example just showing kind of high level how this actually works. We have a server over here which doesn't need to know in advance what the device is, because part of the connection process and bootstrap process is to tell the server what objects are supported by the device. It can then look them up in the OMA registry, and it knows then immediately how to, you know, read, write, manipulate, observe, and display them. So you don't have to rewrite software every time in order to interact with any new device. It means that new device manufacturers can create their new things, and the application software can automatically, you know, bootstrap and know how to use those devices. And here we show on the left how essentially all of those protocol stacks and maybe even part of the application are embedded on the cellular module itself, and then controls and potentially additional processor for the third-party device may be external to it. But on really simple devices, the whole application can be embedded on the LTE module itself, which again really drives the cost down. So why are we doing this? Itron is interested in doing this because we essentially want to expand our business, right? And in order to do that, we need to accelerate IoT solution development. And so in order to accelerate that, we believe that using LTE, NB-IoT, and the integrated standardization of protocols supported by the modules, we can essentially make it much easier for a development community to quickly and efficiently bring their ideas and applications to market, which we can then provide as solutions and outcomes to our customers. And that's all I have for today. I think we ran a little bit long, but we should be able to switch it over to Q&A at this point.
Yeah, I'd like to thank, first of all our panelists. And now we're going to go to the Q&A format. And I guess the first question looks like it'd be a good question for Jamie. Jamie, how does COVID-19 affect shipments?
Thanks, Steve. So when it comes to the module shipments, we'd kind of seen that most of the vendors weren't having too much problem shipping out more product. We kind of need to wait to see, I think, until a little bit later in the year to see for sure what supply chains for OEMs devices have been obstructed most, but we haven't actually seen from the mid-year reporting and the 2019 annual reporting that ended in April of this year, we haven't actually seen that shipment volumes were too badly impacted. Most of the Chinese vendors, they got back on track very, very quickly. And I think most of the European and North American vendors, they're likely to see the major impact, if there is going to be any, to their shipments as of this quarter, the second quarter of 2020. Looking at the COVID impact at large on the IoT is something that we spent a lot of time doing at ABI Research, because we spend a lot of time looking at the total market for IoT devices. And looking at individual end markets, it varies dramatically depending upon the discretionary nature of the spend and how far advanced projects already were in their planning. We've seen an awful lot of an impact on the high value asset market, especially in the fleet sector, fleet transport and tracking. And we've seen quite an impact specifically in terms of NB-IoT in the metering and asset tracking and smart city sectors. With the smart metering, of course, it's been impossible for installers to be able to get into residential properties in order to be able to install meters, as well as to get into commercial properties. But all deployments that have already been planned for this year, we will catch up with them next year. So it won't be a lost market opportunity at all. With asset tracking, we have seen some supply chain issues with the manufacturing of asset tracker devices, but we see them as only becoming even more important to more and more businesses' long-term strategies in order to avoid disruptions to their own businesses in the future. So as of next year and onwards, we only see the asset tracking market accelerating to compensate for the difficulties that it's had this year. But yeah, because NB-IoT is still relatively new, because the shipment volumes are 15% as of the end of last year of the total cellular module market, it hasn't been adversely affected so far by the COVID-19 epidemic.
Okay, well, thank you. I think actually the next one is also for you too. It'd be, what about the agricultural percentage in LP1 LTE or LP1 LTE?
Absolutely. So it's a very interesting area. for the monitoring of the soil as well as for the monitoring of livestock. We divide connected agriculture into two sections, the slow moving machinery that's associated with the farms, and then the sort of the dumb sensor based devices that are deployed in the field to aggregate en masse data about livestock and crops. With NB-IoT, we're expecting this to take off in agriculture into the future. So the 2020 pie chart that I showed for this year would have agriculture coming into the others category. We do see NB-IoT and LPWA LTE at large being very, very useful for the agriculture market. We see it taking off more so from 2022 onwards. It's also interesting to note that when looking at herds of livestock, where you may wish to monitor the way in which they move, as this tells the farmer an awful lot about what's happening with the animals, with their health, whether they're staying stationary for too long, whether they're livestock that are due to be calving, and with the crops that are being grown, you might potentially only need a single sensor per hectare. So even though quite a lot might be used globally, they will be making relatively efficient use of these connected sensors. So there might not be quite as many deployed as people might imagine in comparison to a general purpose asset tracking for industry.
Okay, thank you very much. I think the next question is for Jens.
It's a comment that you can repeat maybe, Jens, a question that we had from Daniel.
Okay, let me, there are lots of questions here. Which one was it, please?
It was specifically, hold on, it's in the chat room.
So it was a question on the range and scale concerns with millions of devices.
Right.
Sending more than per day.
Yeah. So I would say as long as the millions of devices are not in one cell, then there's no problem. So if you have millions of devices spread in a country, I mean, this is exactly what cellular networks have been designed for. So and this, I mean, those millions of devices will also not happen immediately, of course, like from one day to the other. So our operators can always, as the network is being used by more devices, increase the number of cells. So this is what we've been doing for 2G, 3G, and 4G for the last decades. So NB-IoT definitely has been designed for millions of devices. It can also support 10,000s of devices in one cell in terms of idle devices. So you can't have 10,000 devices simultaneously sending data. This is actually also not possible for 2G, 3G, and 4G anyway. Those devices are NB-IoT devices are usually in power saving mode. So the beauty of NB-IoT is that they can wake up, send their data or receive data in a fraction of a second, and then go back to power saving mode. And they can remain attached at the network and wake up and send data at a very little energy expense. So yes, the network does support 10,000 devices, even millions of devices across the country, no problem. There was also a question regarding mechanisms in terms of how do you avoid congestion. So two answers for this. We have something called IoT solution guidelines, urging application developers to make sure that devices don't simultaneously send data. For example, if you have smart meters in one urban region, you should not program them that they send their meter data at 12 o'clock noon sharp at the same time. So you should include a randomization procedure to distribute it over several seconds or minutes. And the other thing is there's something at defined at the GSMA called Radio Policy Manager. That's a mechanism implemented in a variety of chipsets and modules to also have have mechanisms in place to avoid what we call a signal storm, when there are faulty devices or devices that are poorly programmed, the application spamming the network. So in IoT, we don't have those two big operating systems as we have for the smartphone business with Google, Android and iOS. At least we have mechanisms such as the radio policy manager implemented by many or most module and chipset manufacturers.
Okay. Next question. Let's see.
Now we have a questions on lightweight M2M 1.2 from Marianne. Maybe Atem?
Yeah, just let me answer that. So the lightweight M2M 1.2 specification is under work at the OMA and is well advanced. So it should be released somewhere in this summer. In terms of implementation, well, at IoTerop, we're already full speed on that. We already have the support of MQTT transport as software can easily cope with any transport, by the way. So as soon as the spec will be released officially, I mean, our software is almost ready to support everything and go to test testing and certification testing.
There's also questions on UDP proprietary device management solutions, which I think, and the ratio with lightweight M2M, which I think is not necessarily a way to compare the solutions, because you can use partially UDP. There is a question for you, David, related to NB-IoT versus mesh network. Can you give us some insight on how to compare NB-IoT?
We would use both technologies. There are certainly places in the world where NB-IoT is an easy win because the regulatory environment is not really suitable for unlicensed mesh for some applications. But I think I see it more as a mix. Certainly, the other aspect is that with NB-IoT, if you're starting out with a sparse deployment, so things are geographically spread out or there's relatively small numbers, much easier to start small and scale up on NB than it is with mesh. Typically, you know, when we deploy a mesh, it's typically been with, you know, single or just a handful of applications that, you know, we're covering a fairly large area at very high volume. So think investor-owned utilities. That may not be the case in smart cities. You may have, as was shown in one of the examples, there might be, you know, dozens or hundreds of devices of one application, you know, and maybe thousands of some other application. It's hard to address those with a mesh because there's infrastructure required to be installed. Once you're, you know, above a certain mass, if it's like utility meters where it's every house in a dense metro area, the mesh network still may be the preferred method for us. But I look at it as another tool in our toolbox to solve some very specific problems. Water and gas are getting very interesting in North America and Europe with NB-IoT. So that's something to watch. And I know the deployments in China have been quite large in that space.
Thank you. We have time to take the last question. And let's take the one from Gert van der Ricken. So is there any easy way to integrate lightweight M2M on a device by yourself? So the answer is pretty easy from our side. At IoTerop, we released an evaluation SDK of Iowa that you can download from a website. Typically it's released in source code, and it helps you to integrate lightweight M2M very easily on any device, any platform. You can compile in any tool chain and cross-compile it. Well, it will need only like a few minutes to get the things on board and make the few tests on our test server that is also public. available on the website. So you can actually do a prototype in a very light way using Lightweight M2M 1.0 and 1.1 and make it run all the way with the test server connecticut. So let's you can register to the website and get access to it right away.
We'd like to thank our audience and all our panelists for being here today. And this was recorded and we're gonna release this as a recording as well. So if you weren't able to attend the whole thing, of course you can't hear this, but we'll get you a copy of this as well. Thank you very much.